Hi everyone, welcome to another edition of the AnandTech podcast. I'm your host Ian Cuttress. Joining me today on the podcast is one of our newest editors to join AnandTech. This is Nate O. He works with Ryan and doing GPU content.
Hi everyone.
And today's podcast is going to be a little bit special. Aside from the fact that we've had a few podcasts recently, but we had an unexpected invite in the mail a couple of weeks ago. One of the biggest things that underpins our industry is the semiconductor manufacturing industry. It's not a topic that a lot of tech press cover because it's not directly consumer related. It's something that AnandTech takes an interest in because it underpins everything that we talk about. This is an industry where every generation, the companies that are involved on the leading edge of process technology, they bet everything they have on the next generation of process technology. So whether it's somebody like Intel who are betting their next generation of products on their next 10 nanometer process, or whether it's AMD's roadmaps putting all their eggs into GlobalFoundries 7 nanometer basket, it is a very unique industry. But when it comes to semiconductor fabs, so we're talking the four leading fabs being Samsung, TSMC, Intel, and GlobalFoundries. Arguably, they all do what's called Foundry business, where they sell their manufacturing capabilities to companies that want to create chips. Intel is a little bit different because 90%, 95, 99% of what they do is just for them. Basically everything. Whereas Samsung is about 50-50. TSMC is purely a foundry play, GlobalFoundries is a foundry play. But these people are very secretive about what they, about how exactly they do their manufacturing. I mean, sometimes they do a tech day and they tell us things about fin height, pitches, and how dense the features are. But they never invite anybody to actually see how it's done. Everything that everybody sees about this part of the industry comes from vague photos and press releases. So I've been covering technology for the best part of 8 years now. And I've seen inside, say, Gigabyte's factory where they make motherboards and graphics cards. I've seen MSI's factory, I've seen Huawei's factory. But I've never seen a silicon factory, a semiconductor plant. So my surprise when GlobalFoundries PR team reached out to us and said, hey, we're doing a tour of Fab 8. Fab 8 being their semiconductor fab they have, which is the one that's on the leading edge. They said in the email, we invited Anand 8 years ago and thought it was great that he came. Would you be able to make it? I jumped up and down and shook Ryan, our editor-in-chief, and said, we must go, we must go. And literally, this is the second ever media tour GlobalFoundries has ever done to Fab 8. I think they've done one, maybe two to Fab 1 in Dresden in Germany. But this is such a rare occurrence in our industry to be able to go and see a fab while it's working, while it's doing what it does. And it underpins so much of what we do, that, I just had to come. I just had to put on what they call a bunny suit. And I look stupid doing it, but what the hell? This is an opportunity. I mean, Nate, you've been working with us, for a few months now. What did you think when we first said, well, hey, you live nearby, come and see a fab with us?
No, it sounded incredible, honestly. Like, that's one of the things that, it is really, they call it a black box sometimes, right? Some of the people that work there. And it kind of is a little bit. Some of the people that were there, they were saying that, oh, we went to so-and-so fab and all we got to see was this tiny little window through the door. We didn't even get to go inside the clean room at all. But this time, we got a tour through the clean room and the Sub-Fab, so it was really crazy. So
it definitely seems to be the first stage of GlobalFoundries doing more extended media reach out, which I can only express my desire for this to happen, for them to tell us more about what they're doing and to understand their business, because ultimately that makes when we talk about companies like GlobalFoundries and makes our content that you guys read and or listen to just more detailed and more in depth. So the fact that they were inviting press out, so this was about 10 press slash analysts. They initially focused purely on the sort of northeast US for the people who are attending. And then, so this is where I hear you ask, well, why are you there, Ian? You're based in London. So they still had Anand on the email list, and he was based in North Carolina. So we ended up getting an email, and I don't care that it was meant to be northeast US anyway. I was prepared to make the flight over. But it was, a very small group. The start of GlobalFoundries doing sort of more media reach out. There was a little interesting element to the fact that they were saying, hey, come and join us on a media tour. Because usually when a company invites you to see one of their facilities, it's in combination with an announcement or a product.
Or a reason,
I mean, there has to be a reason to go. And ultimately, there didn't seem to be a reason. I mean, during the trip, they said there would be no new information. I'm using new in, quotes, because we did actually find out a good few things that are worth talking about. But they said, we're not doing any major announcements about a new process. We're not going to we're going to talk about what we do, but it's stuff that's already public, but no new announcements. What they did say they would be doing was talking us through their 14 nanometer, their very mature 14 nanometer process that they licensed from Samsung, and also the variants of that process that they have optimized internally. Talking about the new 12 nanometer process that's being used with a few customers. They were going to talk about 7 nanometer, which is their next generation of high performance and leading edge process node, and they were also going to talk about EUV, extreme ultraviolet fabrication process, lithography, everything that is going to be a critical point within the semiconductor industry, within the silicon industry, within the processor industry, within the integrated circuit industry for the next 3, 5, 10 years. GlobalFoundries says that 7 nanometer for them is going to be a super long-lived node, as well as 14 nanometer is. And so bringing us in and to talk about it was something that we had to do. So GlobalFoundries, if you don't know, is their business model is as a foundry. They build silicon chips for companies that want to buy them. They started as a spin-out from AMD. So AMD separated out its foundry business from its chip design business, and now GlobalFoundries runs as a separate entity. They have then since acquired other companies, and there's been this deal with IBM to have a research sharing and team migration. I mean,
and they also took that deal with like $2 billion, and they took the fabs off of IBM too. So they have that new one in Fishkill, or the old one, and the one in Burlington. Both of them used to be IBM, but now they're under GlobalFoundries. So.
And they're within a couple of hours drive of where we were. So
that little northeast corridor, it has so they do most of their R&D actually in Albany. With the University of Albany, they have like the College of Nanoscience Engineering or something like that that's been sponsored. So they work with IBM and Samsung there.
And in fact, most of the people who we met today at GlobalFoundries, they told us, 25 years IBM, and now they've been 3 or 5 years GlobalFoundries, and necessarily what they do hasn't changed, but the way that it's been structured means that there's more vertical integration and more synergy, and it's helped them as a business have that deal with IBM, and it's helped IBM maintain its research and focus on without worrying about how to manufacture chips to a certain extent. So GlobalFoundries has many customers. They don't talk about their customers unless their customers want them to talk about them. So GlobalFoundries' biggest customers are AMD, obviously, and IBM, obviously. They also have other big customers which they don't talk about, and then they have lots of smaller customers that use maybe some of their older processes. So they still run a fab that produces 180 nanometer chips, and they have other fabs that do other intermediary process nodes, ones that may be more suited to other types of silicon like IoT or radio frequency type silicon. So GlobalFoundries has a lot of fingers in the silicon pie. In terms of scale, they're about a sixth of the size of TSMC. So they very much are the underdog in terms of the foundry business. That doesn't necessarily stop them much in any way. It's a very much an underdog mentality. They have to think outside the box in order to be at the leading edge when they've got such a major player who has a lot of customers. But GlobalFoundries. So we're currently sitting in New York. The fab that we visited, Fab 8, is based near Saratoga Springs in a place called Malta. It's a very well. I was going to say it's a very long, sort of 3-4 hour drive. Though we spent most of the time talking on the drive, and it kind of went pretty quickly. And it's beginning of February, and it's very cold up there.
It's just like normal upstate New York. Like it's just kind of, it's pretty, and there's nothing there, and it's kind of cold. So.
Well, 15 degrees Fahrenheit, and apparently this weekend it's their Chowder Festival weekend. I'm not interested in chowder. I'm more interested in semiconductors. But yeah, so the idea of this trip was to visit the clean room, where they make the chips, to visit what they call the Sub-Fab. So this is under the fabrication floor. They have to have infrastructure to supply the equipment with all the chemicals and the cooling that they need, and it is almost construction site like. I mean, we'll go into it. I want to specifically spend some time talking about the clean room and some time talking about the Sub-Fab. We were given talks by a couple of the SVPs and executives of GlobalFoundries. Specifically, we had a talk from Gary Patton, the Chief Technology Officer of GlobalFoundries, and Thomas Caulfield, the general manager of the Fab 8 facility. And we also reached out to GlobalFoundries early in their process of inviting media. I managed to get a one-on-one, a two-on-one interview with Gary Patton, the CTO. And so we recorded that earlier today in the afternoon. I've sent that off to one of our editors to be transcribed, and we'll hopefully get that out to you very soon. It might even be out before the podcast is. So, I mean, let's go through the trip. I kind of want to go through the trip in the order that I did it. So, I mean, there were 10 press. They split us up into 2 groups of 5. For some odd reason, Nate and I were split up into different groups. But ultimately, I think, actually, that gives us a chance to have different perspectives on what we saw. And we also got told different parts of the facility, even though it's the same guides. So let's start with what I started with. So I went to the clean room first. The where they make the chips, where they move around the wafers, where they do the deposition, the etching, where they blast everything in order to create the Ryzen processors, the IBM Z processors, and it was fun. Now, clean rooms are, it's self-explanatory. These processes that make the chips have to be so carefully controlled down to even the nanometer particulates in the air. If you're designing a chip with several billion transistors, you do not want any defects. If somebody's stray hair goes in,
smaller than that, really.
Well, no, that's what I'm saying. So I was told the clean room is a deodorant-free zone. That puts it into perspective. Somehow we were given special clearance to wear deodorant, but in order to get prepared, you have to go to to an extreme with regards to how what you're wearing. So this is what's called a bunny suit. So the clean room is what they call a level 3 clean room, because there are different grades of clean room about how dirty it has to be. How clean it has to be. So we've done a bunny suit. So this is a very specific type of hood, an actual suit. We had to wear covers over our shoes, and then put on special shoes over the covers over our shoes. 2 sets of gloves, so cloth gloves, then nitrile gloves. We weren't allowed to take anything. We weren't allowed to take anything in that we could take out of our pockets. Should say absolutely no pictures, because this is all sensitive IP. We literally have to paint you a picture of words. And when I come around to writing our trip up, I'll try and paint pictures of words rather than, bullet points.
You didn't have to wear the beard, did you?
No.
You had to wear hairnets as well, and for people who had even stubble, sometimes they just gave them, the beard covers.
Yeah, no, I'm sporting a 3-day stubble, but no, I didn't have to wear that, thankfully. But yeah, no, face masks and special wires in it pinched so it's close to your face, so when you're breathing out of your nose, you're not breathing your germs everywhere. So it takes a good 10-15 minutes to get into this kit, and when you put everything on, you have to sort of stamp on a blue sticky floor. I mean, this is literally to get the stuff off the bottom of your shoes, and even off the stuff which you've just put on, which has come out of a nitrogen sealed plastic bag, because that's how they buy them, and they get sent away to be reused when to be washed and then repackaged when they're done. But yeah, even having a blue sticky floor, I mean, it was to a point where they would have 3 or 5 people go across the blue sticky floor, make them stamp on it a few times, and then they would sort of like peel a layer away, so there was a fresh sheet of sticky underneath.
Not even that. At the end of the day, they take the whole thing off and then put another stack in.
Yeah, this is ultra requirements to keep this room free of somebody's stray germs. Which is fair enough. This is, I'm surprised that processes work after seeing what we did today. So as we go in, no pictures. We were allowed to take notes, but we weren't allowed to use our own notepads and paper because they are too dirty. So they gave everybody the opportunity to. I'm holding mine here. It's like a vinyl notebook. And I don't think the pens were necessarily anything special. They seem to be standard.
They do say clean room on it.
Standard biros that say clean room. But we were using that to write our notes, because as we were going through the tour, the amount of numbers we were being told and of everything that was going on. I mean, I like to think I have a good memory. I don't think I would have remembered everything that was said, but fair enough. Take notes. So we enter the clean room. In these bunny suits, sweat slowly starting to build up in your pits, because you are in several layers of warm clothing, and then you feel for the poor souls that spend 12 hours on the show floor, on the factory floor with no deodorant. But then we go in, and the first thing you kind of notice is a change in the air pressure. So clean rooms are designed such that the parts of the process that have the opportunity to contaminate the wafers make sure that everything goes from clean to dirty. So when everything is blown out of the system, the most contamination potential is nearest the exit. So there's that.
It's like if you have a chassis and you have more intake fans.
Oh yeah. So positive air pressure and negative air pressure. But, you walk in and you are presented with a room full of equipment that looks very white, as, people expect to see on pictures. The room itself, so there wasn't white light that you might expect. It was a sodium yellow light. So if anybody remembers the old street lamps where they have so sodium has 2 particular wavelengths, I think, around the 620 nanometer mark. Yes, that's me trying to remember my my chemical physics lessons. But it was bathed in yellow light, and why is it yellow? Why is it not white? And then we were told to kind of look up to the ceiling, and we're looking up, and there are masses and masses of tracks and machines running along the tracks. So we were told that, within the clean room, so the clean room being about 450,000 square feet, they have 15 miles of tracks, which have machines that go around the whole facility. And what they're carrying is so they carry two types of things. One type is called a FOUP, FOUP.
Front opening unified pod. That's what they call it.
Apparently, this is a standard, but it's a pod that holds 25 wafers in a black sealed box. And the reason why it's black is because when a wafer has photoresist on, you don't want the ambient light interacting with the photoresist and screwing up what you're manufacturing. But these FOUPs are designed to be carried from machine to machine through using these automated they're automated machines, so that they get put on, say, a lithography machine in a standard capacity, and that goes into the FOUP goes into the lithography machine, where it can then be opened up, under dark and be used to, do the lithography. It's late, and so then it comes out of the machine, and then it gets taken off to the next one. So all the wafers move around. There are, aside from FOUPs, they're called
FOSBs,
FOSBs,
front opening shipping boxes, apparently. So those are transparent. Those are, I think, raw or finished. That it doesn't matter if light gets in or not.
So raw materials, so completely fresh wafers, or even completely fresh elements to certain machines. So, I mean, this system could send anything it was programmed to anywhere in the fab. But yeah, or finished wafers. What do they say? Potential for $250,000 worth of nicely fine silicon, which suddenly goes disappearing. No, I didn't get opportunity to get anything.
So, I mean, just to get a bit I guess if you try to picture it in your head, it's like a whole bunch of crates going all over the place, in a highway that's attached to the top, of the ceiling. So they likened the FOUPs and the FOSBs to vinyl boxes. So instead of vinyl, it's silicon wafers, and they're just traveling all along. Everything's automated, and they kind of stop and go like traffic, except they're all automated. So
well, so this is the thing. We were told that this clean room is the most automated factory in the US.
They said, I think, compared to all other fabs, they said they're 90% automated, more so than the other ones. They were able to do that because they started from scratch the fab and purposely made it automated that way.
So the only physical humans on the fab floor are people doing maintenance, or people having to do random checks. There is nobody involved in the manufacturing process. The carts going along these tracks, this highway, they are sending their position to a central control facility 100 times a second. So they know exactly where they are. They know exactly where they have to go. If there's an issue, it gets flagged in the system immediately. And maybe that cart goes off to the repair facility, or somebody has to come out and sort it.
They make this beeping sound. Did you hear? It's like Mary had a little lamb, but in a chirping sound.
So I was told the carts make that noise when they can't read the ID of the FOUP they are carrying.
I see.
So they've been told to go pick up a certain FOUP, and they do, and they assume it's the right FOUP, but they continually check to make sure that nobody's sort of kind of replaced it. A fully automated, 0 people operation, except for maintenance and repair and monitoring. So the clean room itself, I said it was about 460,000 square feet. What they split the clean room up into what they call 3 phases, and the phases are based on when those parts of the building were built. So phase 1 was first, then phase 2, and phase 3 is currently in the process of being fully put in, as I understand it.
I think they mentioned that phase 3 they used to use for R&D, but at this point they kind of cleared it out, and then it's just being used for, production, like the other 2 phases.
And it sounds like they need more and more capacity. But the whole facility can do 60,000 wafer starts per quarter, or 20,000 wafer starts per month. Compare that to some of the bigger semiconductor factories that can do in excess of 1 million wafer starts per quarter. It's still very big. It's not necessarily the biggest, but it is the most automated.
It's also, this is solely for 14 nanometer and also technically 7 nanometer that they're ramping up. So
yeah, I mean, this is their leading edge factory. So 14, 12, and 2B7 and 2B EUV. The fab is powered. I mean, how do they do all this automation? Well, they have 3 data centers on site to drive all this automation. Why do they have 3? The answer I got told was redundancy.
It's always a good answer, technically.
Yeah. What do you need 2 levels of redundancy? I mean, we were told that these data centers are hundreds of servers big, so you're having hundreds of data servers doing the control, then hundreds of data servers doing the backup, and then hundreds of data servers doing the backup. I mean, this is a facility that runs 24/7, so that it has to be up and running all the time. Any downtime or any time a machine isn't being used is potentially wasted. So the processes and the orders have to be optimized to keep the machines at 100% utilization. Actually, I want to go back to the tracks, because one thing that they said is, so when you have a bunch of wafers that are ready to go into a machine, they may have to wait for other wafers to be processed first. So technically, they have to be stored somewhere. Now, the conventional way is to essentially keep the storage by the machine. I mean, like you're physically just waiting to go in beside the machine. Now, GlobalFoundries are using their track system to transport all the wafers. They're also using the track system as a form of storage, but they're storing wafers that need to be processed by a certain machine above the machine rather than beside it. And the reason is because this reduces a machine's XY footprint. So when a machine would necessarily, process so many wafers in a given time, if you had a certain amount of storage next to it, sort of in the XY plane, it could add an extra 10 feet to the machine. And then suddenly you've just lost a whole row of metrology machines that do the monitoring. So they changed the way the machines work by having storage bins above each of the tools, which is fair enough. I mean, their premium is XY space. Their premium isn't Z space. With clean room, we were told that if you look at how much the whole clean room costs, you're looking at about $5,000 per square foot, or $3,000 to $5,000 per square foot. It kind of feels like that house prices in London are going that way right now, and they're looking at innovative ways in order to improve both the workflow, reduce the costs, and to a certain extent that might sound silly, because every business should be looking ways to reduce costs and improve efficiency. But our tour from the GlobalFoundries rep was very enthusiastic that this was a key part, and they say they've even patented certain elements of their design to keep it the way they have.
They're kind of pushing it as their, I suppose, killer feature, right? That it's so automated, and at no point is a human really touching the wafers or moving the wafers anywhere. So this is their way to kind of get an edge on other fabs that simply haven't been built this way or don't use this level of automation. So
how long does it take to build a new fab? 2-3 years, and then fit it
much
out
money,
and optimize
really?
it. Yeah. So, don't get me wrong, very, very, very impressive. And they were saying that for one of their standard 14 nanometer chip designs, that you're requiring 60 masks and photolith steps, and something for 7 nanometer will require 85. Which is, talking about 7 nanometer in the clean room brings us on to EUV, the next stage of, tools to be used in the manufacturing process. So GlobalFoundries has officially stated that their first generation of 7 nanometer will still be using the same sort of processes they are now, using 193 nanometer argon fluoride stuff. Lasers, yes. And using quadruple patterning in order to get the metal layers at the right size and density. What they are doing for their second generation 7 nanometer is implementing EUV into certain parts of the steps to reduce the number of overall steps. So there's a time benefit analysis, there's a cost benefit analysis, but EUV has been talked about for 20 years. So the fact that it's almost getting ready now means that GlobalFoundries is now putting in the machines into their fab. So we're in the clean room. We move from the phase 1 part of the building into the phase 2 part of the building, and we see the giant logo ASML.
Well, ASM, they didn't put the panel.
Oh, they even had the SM. I only saw the A. So they obviously
work fast.
I mean, you went into the clean room after me, so they had obviously put in that. So I did see a lot of pipes going in.
Gotcha.
Very complex machines. But so GlobalFoundries has retrofitted part of their phase 2 side of the clean room building with room for 4 EUV machines. They currently had one that was installed but being calibrated. They had a second one that was almost in bits waiting to be constructed. And then they had space for a third and a fourth, but they haven't purchased a third or a fourth machine yet. Technically, they do have a third that is with ASML as part of their development cycle, which they could pull out if they wanted to bring it. But I mean, we did speak with Gary Patton about how they think do they worry where their third and fourth tool is going to come from, and he said that they don't that even though they've not been purchased yet, he doesn't think that getting one will be an issue. But hey, you've got EUV machines that they say are in the process of being these. So I mean, if you look at the lifetime of these sorts of machines, the biggest cost is actually maintenance, keeping the machines up and running. So, but because these machines are so complex, in order to get into the machine and in order to fit and replace parts that need repairing, you need to be able to pull them out. Now, because of the complexity and the density of these machines, GlobalFoundries actually had to install cranes over each one of the 4 bays for the EUV machines.
Apparently they needed those to even bring them in after they cut a hole in the wall or whatever because the machines were too big. So these machines are like 5 times the size of the normal tools and of normal, I'm kind of guessing, but that's how large they are. So
I was told they actually had to cut a hole in the roof, and then increase the available Z height they had in the clean room in order to put these in. But so of the machines that they had, it's not GlobalFoundries doing the installation of these machines. Actually, ASML have dedicated teams who install these. And based on when the EUV tools were purchased, the first one came in and they had a team doing specifically the installation. Then they moved on to the second machine and started installing the second machine. And they used they're using what they've learned from the first machine. Inputting the first machine to then use that experience for the second machine. So it's not a case of they bought 2 machines at once. They actually bought them staggered. But we were told that since it's been 13 months for them to just to install the first machine. From initial plans that required retrofitting. There's also a lot of work in the Sub-Fab that has to go on. So 13 months might sound long, but pretty sure the second, third, and fourth machines will, very quickly follow. We were told that currently the installation has, the purchase and the installation and the preparation has cost GlobalFoundries $600 million. I'm not sure what you think about that number. For certain ways in my mind, I think, actually, that's quite cheap. And in other certain ways in my mind, actually, no, that's very expensive. I mean, somebody give me $600 million, I probably won't spend it on EUV. But so yeah, EUV is a technology that they plan to bring in for their second generation of 7 nanometer. Though, depending on how and exactly when it's ready, there are some complications that we might go into in a little bit. But they're initially going to introduce it for the contacts and vias, so they're going to keep it away from the critical paths of chip design. They're going to make it so any customer that builds a high-performance chip on the 7nm non-EUV process can hope it should be able to replace some of the metal layers with a single pass with EUV, and there'd be negligible difference in from the point of the chip designer for power performance, and all it does is it increases the throughput of the system and makes the process slightly cheaper. The EUV reduces 3 layers of the process down to 1. Technically, the throughput of the machine drops. So with a standard 14 nanometer process, those machines can process 275 wafers an hour. These EUV machines are supposed to be rated at 125 wafers per hour. But if it's doing the equivalent of 3 times the work, you're essentially going from 275 per hour to the equivalent of 375 per hour.
And each layer, too, that they remove, it's not, again, one of them was talking that it's not just like one step. Each layer requires like multiple steps and multiple chances to introduce more defects. So even if it's just 3 steps, it's like there's sub-steps within it. So you're actually avoiding more possibilities for defects.
Which increases yield, reduces cost, and higher throughput. So the first change of introducing EUV just to contacts and vias should be, as long as the EUV works, should be easily implementable. When they're going to use EUV more extensively in a 3rd generation of 7nm, that's going to require a bit more work from the chip designers to actually make that happen. So it's not going to be such a simple process. But we were told that, don't expect EUV in 2018. Apparently they already have customers chomping at the bit to say, get it done, get it done, get it done. And they have to turn around and say, it's not done yet. Queries things do require time. Speaking with Gary Patton, the CTO, he has no qualms. He has no issues and sees no distinct problems in the horizon. He fully expects EUV to be a part of their 7nm process families. It seems like in 2019, or at least risk production in 2019, which is fair enough.
Right. He was saying also, there are customers that want 7nm now. So instead of just telling them, oh well, we can't have it until EUV is ready, they're just going to keep going with optical and just quadruple patterning. And then just get it out to them. Yep.
The last element I saw in the clean room was the control center, where they do the monitoring of the clean room and also some of the maintenance. And they said they have 6 people on maintenance at any one shift and 7 people doing the control. So I'll clarify. When I say maintenance, I mean when a machine needs to come in and be tinkered with, they do it in the control room or next to the control room. But out of the other 7 people who are doing the monitoring, one of them stays in the monitoring room and uses a radio to talk to the other 6 people on the floor. If one of the FOUPs or the carts has had an issue, or a system's had an issue, to go and fix it, and they switch around every couple of hours, because spending 12 hours in one of those bunny suits.
Yeah, that's...
Yeah.
Don't forget the cleaners, too. There's basically always some people that are going around vacuuming and just cleaning the floors all the time. So. They
take clean room very seriously. Especially with a bunch of grubby press walking along. I did ask one of the guys, how long do they have to budget for if they want to go use the bathroom while in a bunny suit? I didn't get an answer to that question. But given how long it took us to get in and out, I can imagine it easily being 20 minutes or so. But okay, so the clean room was meant to be the highlight of the trip, and up until today, I always said the best part of, say, a factory tour is getting into an anechoic chamber, getting into one of those soundless rooms where you can hear the blood rushing through your ears, because it's an experience that press who have never been in one, they will remember, or they'll get freaked out, or they'll enjoy it, or
All of the above.
I know. I say I would love to sleep in one because I live next to a busy road. So getting an opportunity to go into a clean room, it's on another scale of, the opportunities that we get to do in this job. And, I would love for all of our readers who are interested in this sort of thing to be able to do what we did. And I'm sorry, I can't get you in. I don't have clearance. But as important as they are for our industry, and, I can't compare it to any other clean room because I've not been in any other clean room. But I've been doing this job so long, and I've only been in one clean room. So
what we're saying is it's really cool, but you probably won't be ever be able to get in one.
No. I'd say it's really cool, and if TSMC ever want to invite us to one of their clean rooms so we can do a comparison, please get in contact. And this trip that we've done, I want to write it up. And just to clarify, GlobalFoundries invited us; they didn't pay for anything. So we want to write this because we find it interesting, and we think you'll find it interesting, not because money's being exchanged or anything. So, moving on from the clean room, the next place I went into was the Sub-Fab, the underneath the clean room. I mean, Nate, you went into the Sub-Fab first, so maybe you have a different opinion here. But the idea of the Sub-Fab is that it contains all the pipes for the cooling, all the chemicals that get sent up to the fab. It manages all the waste. This all has to be done underneath the fab. So what they have is they had the clean room on the third floor, and the Sub-Fab was on the first and second floor. Essentially, it was just all one big high rise in Z height. And we were told that you need about 6 feet of Sub-Fab space for 6 square feet of Sub-Fab space for 1 square feet of fab. So for clean room space. So when you have about 500,000 square feet of clean room space, you need 3 million square feet of Sub-Fab space.
So what they kept using the analogy was like an iceberg, like the top of the iceberg, the very pretty part is the clean room, but everything else, every single thing that powers the tools, maintains them, cools them, all that stuff is in the Sub-Fab. So
you can tell that as much as an impressive operation the clean room is, the Sub-Fab is the more nitty gritty mechanicals of everything in the Sub-Fab is done at scale because you need lots of chemicals, you need lots of reagents, you need lots of cooling. Yeah, whereas in the clean room you're dealing with nanometers of doping materials. So we were told in the Sub-Fab that if you need Sub-Fab space for things like EUV, it's going to require more space than Sub-Fab stuff for DUV for optical. 7 nanometer requires more subspace than 14 nanometer. So as you go down the process nodes, you're just going to need bigger and bigger and bigger spaces. So if you have your 500,000, 460,000 square feet of clean room, underneath that you have 460,000 square feet of Sub-Fab, and then you need 6 times that dotted around to be and have easy access straight into underneath the clean room. So the Sub-Fab has what they call a sealed pop-out for all the pipes that go into the clean room. These are sort of 12 to 18 inch pipes that inside may have the separate pipes for all the chemicals and all the reagents. These are absolutely sealed. I mean, they're sealed so contaminants from the Sub-Fab don't get into the clean room, but technically the air pressure is such that if there is complications, then actually the air pressure goes down into the Sub-Fab, so contaminants go out the Sub-Fab rather than up into the clean room. Fair enough. One thing I did notice is that there were a lot of pipelines labeled slurry. Now, whenever I hear the word slurry, I think of not very nice smelling material found on a farm. But no, I was told that this is what they use is called polishing slurry. So when they're doing the grinding, when they're doing the lithe, when they're doing the etch, they need to keep polishing the wafer, and they said they use up to 30 different types of slurry. So I mean, the chemicals involved, if you've ever seen like a manufacturing plant where they have a big block of aluminium and then they use a 6-axis thing to actually make, the gear lever that they sell on your stupid car. That they continually use, polishing slurry for that. So that was how it was explained to me. And so some of these slurries are apparently unstable emulsions, so they have to mix them on site, and they have massive bowsers for that. And again, you just see pipes that say slurry, and it's not a farm, I promise. They also have to bring in inert gases, because when you're dealing with wafers, you want to be able to control the atmosphere so nothing reacts. So you buy. They said they use a lot of esoteric, or at least a few esoteric inert gases. I mean, aside from the noble gases like neon, argon, probably a little bit of xenon even. But everything, things like nitrogen, which obviously gets used a lot, as it's a lot cheaper and inert. They actually make that on site. For some of the things they do, they actually also need oxygen, and that's also produced on site. It's cheaper for them to make it than it is for them to buy it.
I'm pretty sure they said they needed hydrogen for EUV, so they had to get a lot of that or something like that.
Oh, did they say if they actually produce the hydrogen?
No, they had to.
They have to buy it in. Yeah. Also, the Sub-Fab deals with all the cooling and some of the reagents that require water. Now, obviously, you're not just going to get water out the tap. You're not going to get water out the stream. You for a lot of what they need ultra pure water. So they actually make that on site. Now, I say they don't get water from tap. They actually take the water from the Hudson River.
Do they really?
Yeah. But that goes through their filtering process. They use ion exchange columns to do that, and they use 4 million gallons of ultra pure water a day. I had to ask. That it actually use US gallons, not UK gallons, because we're in America. But that's a lot of ultra pure water. They cool it down to 59 degrees. Again, I had to clarify that's 59 degrees Fahrenheit, not 59 degrees Celsius. So that's how they have the water. We also saw a machine and that they told us was part of the water purification, and it said pH 8.77. And I said, so you have ultra pure water, but it's slightly alkaline. And the guide who was taking us around, guy called Mike Hall, so enthusiastic about what he does. He says he's worked for IBM and GlobalFoundries for over 30 years. I want to get that guy on camera. He really loves his job. But he was saying that based on the tools that they use, they actually do need a slightly alkaline ultra pure water solution. It's fair enough. It's something I didn't know. But so when you're using so much water, and they actually have 2 5 million gallon storage tanks on site for if they can't get enough water out of the river, if it's a dry season or whatever. They also have to do their own water waste management for a lot of it. So they'll try and take the impurities that they've introduced into the water out and actually reuse the water. So rather than just getting it and then dumping it, they're actually trying to cycle as much as they can. Because it's green and because it makes sense, and I fully expect it's probably cheaper as well, given that they use so much. We were also told in the Sub-Fab about the electrical capacity of Fab 8. Apparently the site is rated for 120 megawatts, but at any one time they typically use about 93, and in the summer that goes up to 100. But the whole fab is using that 24/7. And they don't generate their own power on site. They have to take it from the national grid. They said they have 2 150 kilovolt lines from the national grid, which they use steppers and transformers internally to take it down to what they want. They do have a backup power system, as you would expect a facility of this size to have. They call it the critical power system, the CPS. We were told that this system is designed to provide 39 megawatts, and they take that power from flywheels. Flywheels as an energy store, as opposed to, say, big batteries. Power stations use flywheels to make sure that power is regulated to the national grid. So Flywheels aren't new. They said they actually have a couple of different types of flywheel. I actually managed to extract some numbers out of them. So they have 10 lots of 24-inch flywheels that run at 3600 RPM that are high mass. They have 12 bigger 36-inch flywheels that run at 16,000 RPM but are at lower mass. And we were told that, from it, if at any point they do need the critical power system, it can take over from the national grid in 3 seconds. Chances are that if that happens, you're going to lose whatever wafers are currently in process. But it means that everything that's being held up by the carts on the tracks is going to be fine. But no, they said they've only ever had to use the critical power system once, and that was due to an accident. But most of the wafers that were currently in production at the time were test wafers, so they didn't lose much in the way of product for customers. But we were told that, on a full scale, that they've been running Fab 8 at 100% capacity for the last 5 quarters. So what's that? That's Q4 2016, then the whole of 2017. What products came out in 2017 that required the fab to go into full march? So everything that's being made at Fab 8, customers can request more capacity, but they either have to pay more or ask GlobalFoundries to build more fab. But they're working on 7 nanometer. They're working on EUV. I mean, that was pretty much it for the Sub-Fab tour. I mean, I think the iceberg analogy is quite good, because for as much glitz and glamour is in the clean room, and ultimately it's most of the clean room is the one that usually gets all the praise because they're the one that's producing the end product. The Sub-Fab is essentially the heart and the soul of the fab itself, because that if that wasn't there, if there weren't the people there, nothing would happen up top.
They kept saying also that I guess the Sub-Fab was really clean, at least compared to other Sub-Fabs, but it's equally, I guess, as regimented as the clean room. Like, there's tape for any item that could be moving. Any forklift has a specific place to live. Any ladder, anything that could be out of place has a taped place to be. So,
So in factories, and it was obvious in fabs as well. If there's ever a problem with a machine that requires an immediate shutdown, you have an immediate stop button. And in Fab 8, these are called emo buttons. So it doesn't turn you into an emo, but the idea is that it puts the machine to a complete stop. So we were going through some of the Sub-Fab, and the guide was saying, these buttons, they're a very critical safety aspect of what they do, except that sometimes, because of the cramped space and the buttons are designed to be easily pressable, sometimes they accidentally get pressed. So they sometimes had to engineer kind of low-tech solutions to still make the emo buttons reliable, but be less likely to be accidentally bumped.
It looked like a tape roll that they put on it, honestly.
Yeah, I mean, they said, for as much high-tech equipment as they have above them, sometimes it's the low-tech solutions which put the smile on their faces when bad things don't happen.
Oh, one more thing, I guess. I don't know if they showed you this, but they had that whole 3D modeling thing, right? So they had, I guess, contractors with laser surveyors going all around, and they keep doing that. And basically, they have a 3D model of the entire Sub-Fab space with every single pipe, whatever, detailed out, so that whenever they need to correct something or they need to fix something.
So, yes, I did see that. So they were saying that because the EUV machines were being retrofitted into places where other machines already had been. So the Sub-Fab underneath was already had been set up for the machines that were there in the first place. So when the EUV machines come along and they have a different set of requirements, the Sub-Fab has to be built in such a way that accommodates them. But if you've already got pipes and cables in there, you have to be able to fit what the EUV machines need in a certain way. So that's where the modeling comes in. And then when they send the schematics out for, say, a pipe to be manufactured, the pipe would come in, they'd stick the pipe in, and then they'd use the laser machines to do a pass around where the pipe is, so what actually happens in the fab matches what happens in their plans. This was previously done with a person with a tape measure, and they said with the laser tools that they use, they could easily, survey 100 different points within a very small area within a given day, and that used to take a week with a guy with a tape measure. But they were using external contractors for that.
Right.
And they're saying that usually at any one time they have about 300 contractors on site for, and that can go up to 3,000 when they're doing something big. This is compared to the whole site, which has 3,300 employees, ranging from machine management, machine repair to, I think they said they had 600 R&D staff on site. Mm-hmm. But then you've also got to have people who, manage the wastewater. You've got to have people who manage all the explosive, there's a great room called the pyrophoric room, for all the chemicals that combust when exposed to air, like phosphorus and lithium and all the nice Group 1 metals.
Sorry.
Go on.
I was just going to say, so some of those extra people too are just kind of permanent fixtures, especially the ASML guys for all the tools. They just kind of never leave. They're just always there to maintain. So even if they're not technically part of the 3,300 people, they're just always there anyway. Part of the
300 contractors that are currently on site. Yeah, I mean, so that was a Sub-Fab. Again, such an important part of what is a very critical element in our industry. It's we can talk about things like smartphones. We can talk about things like graphics cards and PCs and laptops, and then actually that 150 square millimeter piece that's taken several months to make and several thousand people and several $1 billion worth of investment just to get through is rather amazing that these things even work. So all credit to people at the foundries, and thanks to GlobalFoundries for actually letting us walk through and grub things up.
Let everything,
Yeah. I didn't see anybody lick anything. If you lick it, it's yours. Is that how it works? They did give us a little bit of other info. So they're expecting their first 7nm tape out at the end of 2018. That's going to be a fully optical process. They said they've got 2 big customers coming on board in 2019. They weren't at liberty to say who they were, but these are people who are going to be big into 7nm. So
and not not AMD or IBM.
No, because they're already customers. So these are 2 new big customers. They also said regarding their 14nm production, they've actually added 60% capacity over the last 3 years, either by installing new machines by phase 3, or just redesigning their clean room and Sub-Fab to be able to cope with just pushing out more wafers. And
it's been at 100% capacity for the past year. So
past 5 quarters. So the rest of the tour we had was sort of presentations and interviews, and I rather than talk about them on the podcast, I'd rather write them up because they were pretty detailed. And we did talk about things like 22 FDX, GlobalFoundries FD-SOI, and also their 12nm FD-SOI and GlobalFoundries radio frequency capabilities, and how things are moving forward and how they compete against a TSMC who is 6 times their size. It was, I've been on several factory tours, and this is a slightly different tour, but GlobalFoundries seemed to have a lot of confident people. Whether it was the the CTO who was very adamant that EUV would definitely be using 7nm, and they've got no qualms that 7nm will be a long-lived node, all the way down to the guy managing areas of the Sub-Fab. He's not on the critical end, but he's still a critical part of the process, and he wanted to grab life by the horns.
The guy who showed us around in the clean room, he kept saying his job was all about efficiency. Any small thing that went wrong was money out the door. He was just... It's kind of impressive to hear that, I guess.
So we're coming up to about an hour on the podcast, and I think we'll cut it there. And it's definitely one of the highlights of my career in this industry so far. And I fully hope GlobalFoundries gets involved in the media a lot more in the future. And I'm trying to push that to make it happen. And if companies like TSMC also want to do that, or Samsung Foundry, then we want to talk. You know where to find us. So I want to thank Nate for his first podcast.
Yeah. Sorry for the coughing.
No, it's all right. We'll get you on some more podcasts. It sounds like you want to come and do a few more events for AnandTech. So I think
I've been a little spoiled though. I mean, having the clean room visit on my first ever factory.
Yeah.
Like I can't expect that to happen.
It's life goes downhill from here. Right? And thanks to you all for listening, and we'll catch you next.